Today in this section we are going to explain qualitative analysis of organic compounds. Okay, qualitative means it comes from the word quality, so it means we want to identify our organic compound. So qualitative mean identification of something. Okay, so mainly our organic compound, any organic compound contain two main atoms, the carbon and hydrogen, and there may be another atoms that can exist, accessory atoms like nitrogen, sulfur, or a halogen like chlor, brom, iode. Okay, so our target in this section to identify the carbon atom and the hydrogen atoms that exist in all organic compounds. Then we will identify the presence or the absence, it may be present or it may be absent, the other accessory atoms like nitrogen, sulfur, and halogen. Okay, so let's first start by identification and qualitative analysis of the carbon and hydrogen atom. In order to identify the carbon and hydrogen atom, what we will do, like here in this slide, we will get our organic compound and we will heat it with copper oxide. Okay, copper oxide is an oxidizing agent. So all the carbon in my compound, in my organic compound, will be converted by the action of copper oxide to carbon dioxide. Okay. Also, all the hydrogens in my compound, by the action of copper oxide oxidizing agent, will be converted to water. Okay, so all the carbon are converted to carbon dioxide, all the hydrogen are converted to water. In order to identify this reaction in the laboratory, we must do something that can be observable in the lab. Okay, so how I can detect the presence of carbon dioxide? By lime water. Okay, carbon dioxide turn lime water turbid. This is a very known reaction. When carbon dioxide react with lime water is the calcium hydroxide reacting with carbon dioxide, give you calcium carbonate and give you turbidity. So this turbidity, when it happens in the section or in the lab, this indicates the presence of carbon dioxide. Okay, and by this, the presence of carbon dioxide indicate the presence of carbon in my organic compounds. This is the way to identify the presence of carbon. We do this reaction, we heat the compound with copper oxide, carbon converted to carbon dioxide by the action of carbon dioxide on lime water, it gives you turbidity. So turbidity indicates the presence of carbon in my compound. Also water, how I can detect the presence of water? By putting anhydrous copper sulfate, is white in color. By putting water on it, it converts to hydrous copper sulfate and it is blue in color. So the blue color of the hydrous copper sulfate indicates the presence of water. And water indicates the presence of hydrogen in my compound. Okay, so this is a way to identify carbon and hydrogen in any organic compound. So this is the first part of the section. We finished it. I told you first that there is other accessory elements or atoms that can be present or absent. So we'll detect it. Nitrogen, sulfur, and halogen. Halogen, we will study the chlor, brom, and iode. How we can detect this? By a very known test called Lacene test or sodium fusion test. What we do in this test? We get the organic compound that may contain nitrogen, sulfur, or halogen, and we heat it with sodium fusion. We do a fusion between the sodium and my organic compound. So if nitrogen present, nitrogen will react with carbon, will react with sodium to give you sodium cyanide. So all the nitrogen are converted into sodium cyanide. Sulfur react with sodium to give you sodium sulfide. Halogen, if it present, react with sodium to give you sodium halide, either sodium chloride or sodium bromide or sodium iodide. Okay, so all the nitrogen converted to sodium cyanide, all the sulfur converted to sodium sulfide, all the halogen are converted to sodium halide. After this, we add some water to dissolve all this and we do certain filtration, okay, in order to get rid of any impurities, any excess sodium, and then we will work with the filtrate. Okay, we will get the filtrate and we will work with it to detect the presence and to see if sodium cyanide present or not, sodium sulfide present or not, sodium halide present or not. Okay, first of all, to detect the nitrogen. Nitrogen is represented by what? By the sodium cyanide. All the nitrogen are converted to sodium cyanide. How to detect the nitrogen? We put freshly prepared ferrous sulfate. Okay, this is the ferrous sulfate. We put freshly prepared ferrous sulfate. First of all, what happened? Sodium, the excess sodium that we added first in Lacene test, will react with the water that we added to dissolve my all the compounds will give you sodium hydroxide. So sodium plus water to get sodium hydroxide. This is the first equation. Second equation, ferrous sulfate plus sodium hydroxide will give ferrous hydroxide, green precipitated. But we cannot stop here because this reaction does not involve the sodium cyanide. My reaction should and must involve sodium cyanide. So sodium cyanide will react with this ferrous hydroxide to give you sodium ferrocyanide. Can we stop here? Also, we cannot stop here because this sodium ferrocyanide cannot be observed in the laboratory. It does not have any specific or special color or precipitated or turbidity or anything. So we cannot stop here, although this reaction contains the sodium cyanide. So after this, the ferrous will be oxidized by air to give ferric, and ferric will react with this sodium ferrocyanide to give us ferric ferrocyanide, and this compound has is very characteristic color. It's the Prussian blue color. Prussian blue means the color of ink. Okay, blue of ink. So this is my main reaction. Okay, in this reaction, cyanide is an essential part of the reaction, sodium cyanide. Okay, and the reaction produces an observable result. It's the Prussian blue color. Okay, so when I add the freshly prepared ferrous sulfate at my filtrate, if we see this Prussian blue color, so this indicates the presence of what? The presence of nitrogen in my compound. But if this color does not appear, so my compound will not have any nitrogen. So in the exam, when you detect the presence of nitrogen, you should write 6 equations. First equation you write it is the sodium plus carbon plus nitrogen gives sodium cyanide, and then we will write those 5 equations. So to detect the presence of nitrogen in the exam, we should write those 6 equations. They should be studied very well, especially the color of the products. Okay. Now we finish the detection of nitrogen, we will go on to detect the sulfur. Detection of sulfur is very easy. First of all, we said sodium will react with sulfur to give us sodium sulfide. This is the first equation that should be written. After this, we will put sodium nitroprusside. Sodium sulfide will react with sodium nitroprusside to give us this compound. We should not study its name, and it is purple in color. So by the addition of sodium nitroprusside, if we see any purple color, this indicates the presence of sulfur in my compound. If you don't see any purple color, this means my compound does not contain any sulfur. So here in the exam, when he tell me detect the sulfur, I should write 2 equations. First equation, sodium plus sulfur give us sodium sulfide, and then sodium sulfide plus sodium nitroprusside give us this compound or this product that is purple in color, and we must write the color. Okay. Now we finished nitrogen and sulfur. Let's move on to the detection of halogens. Yes, detection of halogens has 2 conditions. First of all, we can detect the halogen in absence of nitrogen or sulfur. If my compound does not contain any nitrogen or sulfur, we will work by a certain way. But if my compound contains nitrogen or sulfur, we should work with another way. So before we detect halogen, we should look in my compound to see if there is nitrogen and sulfur, we will work by a certain way. But if there is no nitrogen and sulfur, we will work by another way. Let's start by the case that there is no or in absence of nitrogen and sulfur. Okay. Okay. In absence of nitrogen, in slide 12, in absence of nitrogen and sulfur, okay, we add directly silver nitrate in order to detect the halogen. So sodium chloride will react with silver nitrate, give us silver chloride. Also sodium bromide with silver nitrate gives silver bromide. Sodium iodide with silver nitrate gives silver iodide. Those 3 compounds have special color and special type of solubility. It's telling you that the silver chloride is white precipitated, silver bromide is pale yellow precipitated, silver iodide is yellow precipitated. Okay. Silver chloride is soluble in dilute ammonium hydroxide. Silver bromide is soluble in concentrated ammonium hydroxide. Silver iodide is insoluble either in diluted or in concentrated ammonium hydroxide. So these should be studied very well. We should study these equations, and we should study these colors and this type of solubility. This is in case of absence of nitrogen and sulfur, we will put directly silver nitrate. First of all, like we said in the exam, we should write the equation of the Lacene test. Sodium plus halogen give us sodium halide. If it's chlor, we will write chlor. If it is brom, we will write brom. If it is iode, we will write iode. And then we will write the equation specific to our halogen. If it is chlor, we will write this equation, and we will write the color and the type of solubility. Also in brom, we will write this. Also in iode, we will write this. Okay, so this is the case of absence of nitrogen and sulfur. But in case of presence, let's return back. In case of presence of nitrogen and sulfur, we cannot put directly the silver nitrate. No, it won't be good. Why? Because if we have nitrogen in our compound, it will give us sodium cyanide by the reaction with sodium in the scene test. The silver nitrate will react with the halogen, okay, but it will also react with this sodium cyanide, giving us silver cyanide that is white precipitated. And if sulfur is present, silver nitrate will also react with sodium sulfide, giving us silver sulfide that is black precipitated. So this white precipitated and this black precipitated will mask our results, will mask the white precipitated, the pale yellow, or the yellow precipitated. Okay, so I cannot work when sodium cyanide is present or sodium sulfide is present, because these precipitated, the white precipitated and the black precipitated, will mask all the other color. If this happens, we cannot identify the white precipitated of silver chloride, or the pale yellow precipitated of silver bromide, or the yellow precipitated of silver iodide. Okay, so first of all, I should get rid of all the sodium cyanide and all the sodium sulfide. How is this? By putting concentrated nitric acid. If we put concentrated nitric acid, all sodium cyanide will be converted into HCN gas, and the gas will be evaporated. Okay, also if we put conc nitric acid, we react with sodium sulfide, giving us H2S gas, hydrogen sulfide gas, and this gas will be evaporated also. So by putting conc nitric acid, we will get rid of all sodium cyanide and all sodium sulfide. After this, we can put the silver nitrate. Okay, so this is very important. In case of absence of nitrogen or sulfur, we will put the silver nitrate directly, and we will write these equations directly. But in case of presence of nitrogen or sulfur, or both of them, we should first put conc nitric acid. Conc nitric acid will be put first to get rid of those sodium cyanide or sodium sulfide in form of gas. After putting conc nitric acid, we will put the silver nitrate in order to get this equation and to see one of these colors. Okay, so this is very important. In case of absence of nitrogen or sulfur, we will put silver nitrate directly. In case of presence of nitrogen and or sulfur, first of all, we should put the conc nitric acid to get rid of all sodium cyanide or all sodium sulfide in form of gas. Okay, this is the colors that we talked about. Silver chloride is white precipitated, silver bromide is pale yellow, silver iodide is yellow precipitated. We said also silver chloride is soluble in dilute ammonium hydroxide, silver bromide is soluble in concentrated ammonium hydroxide, silver iodide is insoluble either in diluted or in concentrated. Okay, like this we've finished our section. So what we took in this section, we took the qualitative analysis of certain atoms that may be present in our organic compounds. We said first of all, carbon and hydrogen must be present in an organic compound. How we detect them? By heating our compound with copper oxide, all carbon converted into carbon dioxide by the action. And when we put lime water, it gives us turbidity. All hydrogen will be converted into water, and when we put the anhydrous copper sulfate, it will convert it into hydrous to give us a blue color. And we said that the carbon and hydrogen must exist in all organic compounds. After this, we took some other elements that may be present or may not be present. They are accessory elements, additional elements, okay, or atoms, like the nitrogen, the sulfur, and the halogen. How we can detect them? By doing Lacene test or sodium fusion test. We get our compound, we heat it with sodium. All nitrogen will be converted into sodium cyanide, all sulfur will be converted into sodium sulfide, and all halogen will be converted into sodium halide. After this, how we can detect the presence of sodium cyanide or nitrogen? By adding freshly prepared ferrous sulfate, and we will write 5 equations ending with a Prussian blue compound. How we can detect sulfur? By putting sodium nitroprusside, that give us a purple color compound. How we can detect the halogen? We said there are two cases. In case of absence of nitrogen and sulfur, we will put directly the silver nitrate, and in case of presence of nitrogen and or sulfur, we should put first the conc nitric acid and then we will put the silver nitrate. So all these equations should be studied very well for the exam, and we should also study the color of all the compounds and this type of solubility in case of halogens. Okay, let's see. This is the type of questions that will come in the exam. In the exam, I will give you a compound like this. I will tell you by mean of Lacene test, okay, or sodium fusion test. This means Lacene test or sodium fusion test will only detect nitrogen, sulfur, or halogen. There is no need to detect the carbon and hydrogen because Lacene test does not work with carbon and hydrogen, has no relation with them. Lacene test or sodium fusion test only detect nitrogen, sulfur, or halogen. So when he tells me in the question by using Lacene test, I only search for sulfur, nitrogen, or halogen. This is our first compound. It contains nitrogen and sulfur, and there is no hydrogen. How I can detect nitrogen? I will write first the equation of Lacene test. Sodium plus carbon plus nitrogen give us sodium cyanide, and then we will write the 5 equation of the nitrogen by putting the ferrous sulfate ending with the Prussian blue compound. Okay, how we detect the sulfur? First we write the equation of the sulfur in Lacene. Sodium plus sulfur give us sodium sulfide, and then the second equation we will put the sodium nitroprusside to give us the purple color compound. Okay, this compound contain nitrogen and brom. First of all, detecting of nitrogen like we did here. We will write the 6 equations of nitrogen. After this, there is brom. We said the halogen has two cases: in case of presence or absence of nitrogen, in case of presence or absence. Here there is nitrogen. So what I should do first? First of all, I will write the equation of the Lacene test of the brom. Sodium plus brom give us sodium bromide. After this, we have nitrogen. So first I must put conc nitric acid. Conc nitric acid will react with sodium cyanide, giving us HCN gas. So like this, we got rid of all nitrogen. After this, I will put the silver nitrate. So sodium bromide reacting with silver nitrate gives us silver bromide, pale yellow, precipitated, and it is soluble in conc ammonium hydroxide. Okay, so this is how we solve this question in the exam. Final compound contain sulfur. So first of all, I will write sodium plus sulfur give us sodium sulfide. Then I will add the sodium nitroprusside to give us second equation, the purple color compound. After this, halogen. Halogen has two cases. Here there is sulfur. So first of all, I will write sodium plus chlor give us sodium chloride. After this, by putting conc nitric acid, we will get rid of the all the sodium sulfide in form of H2S gas. After this, I will put the silver nitrate to give us the silver chloride that is yellow. It is white, precipitated, and it is soluble in dilute ammonium hydroxide. Okay, so this is how we ask in the exam. This is the same questions that will be in the exam. We give in the exam a compound like this, and I tell you by mean of Lacene test or sodium fusion test, please detect the presence of any element by using this test. Okay, so this is how the question is in the exam. Okay, thank you very much.